Hello, sorry, is it audible to you?
Yes, sir.
Okay, thank you. So wait a moment, let me share the screen. Yeah. So what we have to study, that is you shared me the, that is PDF. In that PDF, what are there? Common ion effect was there. Okay, acid base equilibria is there, common ion effect. Okay, so let's try to understand common ion effect. So what is the common ion effect? Can you tell me please anything about this?
Common ion effect.
This is there.
I don't have much idea to common ion effect. It's actually the first time I'm hearing this.
See, that is the, if you see that is the, I'm writing the definition, then you will be able to understand. So here is this one is decrease in, they are saying that is decrease in dissociation of, decrease in dissociation of weak electrolyte. They are saying decrease in dissociation of weak electrolyte on addition of, they are saying on addition of a strong electrolyte, on addition of a strong electrolyte having at least one common ion, having at least one common ion, right? Having at least one common ion. Okay, so two things are there. What two things are there if you keep in mind? That is, one is the weak electrolyte, another is the strong electrolyte, right? Now they are saying, have you heard about the Lee-Chatelier principle?
I have, yes.
Okay. So if you know the Lee-Chatelier principle, then it will be easy. Now suppose from your book only I have taken example, HF is there. HF is weak electrolyte. And weak electrolyte, you know very well, that is it do not ionize 100%. So it do not ionize 100%, means it will ionize, that is the partial ionize means the reversible process. So that is going to be H plus and F minus, right? Now what we are going to do, that is I am adding, that is one salt I am adding, NaF. NaF, it is going to be, that is a strong electrolyte. Salt are the strong electrolyte, strong, a strong electrolyte. Salt are strong electrolyte means it is going to be 100% ionized, and it is going to give what? Na plus, and what it is going to give? F minus, right? These things are happening in the container only. Okay. Now see, that is Lee-Chatelier principle will be applied on which of the following two equations are there. This is just what the concept, decrease in dissociation of weak electrolyte. So dissociation of weak electrolyte will be decreased on addition of strong electrolyte having at least one common ion. Okay. So what we are going to do, apply Lee-Chatelier principle. Okay. Lee-Chatelier principle. Lee-Chatelier. So Lee-Chatelier principle will be applied on which of the following? That is okay, you can apply. Generally it is applied for the reversible process, but here in the system you will find the concentration of F plus F minus. Here suppose it is 50% ionized, 50% ionized, right? And it is going to be, that is 100% ionized because it is a strong electrolyte, 100% ionized. So if I will ask you, that is F minus ion concentration in product side will be high or less?
So if we add F minus, so the concentrate, so are we adding F minus?
See, it is 50%, it is 100%. Okay, so it is going to be 150% total as a whole. If you see, so this is going to be 150%, 150%. So what the Le-Chatelier principle say? Can you tell me about the Le-Chatelier principle?
Yeah, so since we have more F minus, then the reaction will, the equilibrium will shift more to the left.
Okay. So equilibrium will move to the left, shift to the left. In which of the reaction? That is in because this is only reversible. This cannot be. The down one cannot be reversed because it is irreversible process. Yes or no? One direction only.
Mhm.
So which one will go back? That is HF will go back. Yes or no?
Right. Yeah.
Means H plus and F minus is going to combine and it is converting back, backward. Yes or no?
Mm-hmm.
So if suppose H plus and F minus is combining and giving HF, so dissociation of HF is decreasing or increasing?
So this is going to increase.
No, H plus and F minus is going to combine so that it will
Right.
go backward. Now, so it becoming association.
Oh, so it's going to go down.
So, so it is so association is increasing, but dissociation is decreasing. So backward shifting, backward shift. What backward shift means? Equilibrium backward shifting. So now you
Mm-hmm.
try to understand the meaning of this. What is meaning? Again, you can read out this one. Decrease in dissociation of weak electrolyte on addition of strong electrolyte having at least one common ion is known as common ion effect. Can you be able to understand this definition?
Yeah.
Okay. Please make a note of it.
Mm-hmm.
Can I erase this one?
1 second, please. I'm just writing the last part down.
Mhm.
Yeah. Okay.
Okay. One more example is given in your book that again I am taking. This one, see the example question in the form of question. They are saying that is dissociation of which one? Dissociation of HCN gets decreases, no, gets decreases on addition of small amount of on addition of a small amount of NaCN solid to it. NaCN solid to it. Give reason. So how can you explain this one?
Let's see an addition, small amount of initial to go.
See, HCN is weak acid. Okay, this is going to be very weak acid. This is the very weak acid. So very weak acid means it is irreversible or reversible.
So then it
Weak
is
means reversible. Weak means reversible. Okay.
okay.
It is not 100% ionized. Always weak means reversible. Very strong. Case of very strong. It is 100% ionized. So that is 100% ionized means irreversible. Getting irreversible. Now metal metal salt or strong means strong electrolyte. They are the non-metal. HCN both are the all are the non-metal. So it is going to be weak acid. Weak acid implies that weak electrolyte. Weak electrolyte means less than 100% dissociate. Less than 100% dissociate. Of less than 100% dissociate, it means what could be the region? What could be the region? That some of the, if it is ionizing, some of the H plus ion and Cn minus ion again combining to give HCN. Yes or no? That is why less than
Mm-hmm.
100%. So this is the less than 100% ionized, less than 100% ionized. Now you see for the NaCN, if you talk about NaCN, this is going to be a strong electrolyte. Yes or no? It is going
Mm-hmm.
to be a strong electrolyte. A strong electrolyte means irreversible. So irreversible means 100% ionized. 100% ionized. So it is going to give the Na plus and Cn minus. This is the Cn minus. It is going to be what? That is common ion. Common ion. Yes, yeah, no.
Yeah.
Common ion present in both one strong acid and strong base. This is happening where it is happening in the closed system. So what they are asking that Bo apply the Le-Chatelier principle. Just now you told me the Le-Chatelier principle. So if you apply Le-Chatelier principle, so you check that is which side concentration increased in reversible reaction. So here is suppose it is 50%, it is 100%. So total that is what? Common ion is 150%. So Cn minus ion is 150%. So equilibrium, because what Le-Chatelier principle say, in the equilibrium, if the concentration of any substance get increased, so equilibrium will shift in such a way that the increased concentration has to be minimized. So which direction it has to go?
So the equilibrium concentration.
So it is going to be backward side, left side. Yes, yeah, no. So
So
means,
that
equilibrium shift to left. It means what I want to say to you, the equilibrium is shifting to left. So dissociation of weak electrolyte, what will happen? What will happen to dissociation of weak electrolyte? Can you please tell me?
it's going to go down. It's going to
It will
decrease.
going to decrease. So that is what is the required answer. Okay. So
Mm-hmm.
that is concentration of H plus ion decreases
Mm-hmm.
because H plus ion and Cn minus going to combine. So H plus ion concentration decreases, or the another statement what we can write, on HCN ionization, HCN dissociation will decrease. Yes, yeah, no.
Yeah.
Please make a note.
Yeah.
Done?
Yeah.
Can I erase this? Can I erase?
Yeah, you can.
Okay. Now you tell me the one problem here. Question is there. 2 question is there. You can solve it out. Question number 3. When NaCl added to the solution of AgCl, then the solubility of
Mm-hmm.
AgCl decreases. Reason. Give reason.
When I say
Yeah, these are the 2 questions. Can you please explain these 2 questions?
yes, so I think for the first one, NaCl and AgCl, it's because the common ion will be Cl minus.
Hmm.
that is going to cause like the reaction to move to the left,
Hmm,
which is
hmm,
then going to decrease the dissociation,
hmm.
um, and hence decreasing the solubility of AgCl.
Yeah, correct, correct, correct. That is very correct. Okay, thank you.
Yes.
Now, huh.
Question four. This is could I can't read the second word. The second one is.
The concentration of OH minus from NH4OH decreases on addition of NH4Cl salt.
Mm-hmm.
NH4Cl is salt. Cl come
Mm-hmm.
for HCl, that is strong acid. NH4OH is the weak base. This is the weak base, right? So one is
Mm-hmm.
the strong portion. Here Cl is comes from strong acid. So it is going to be strong electrolyte. NH4Cl, if you talk about, this is the strong electrolyte. Strong electrolyte. But if
Right.
you talk
So.
about NH4OH, so NH4OH means this is what? Ammonia combined with water, NH3 plus H2O. So this is weak base and this is weak acid. So it is forming NH4OH. So both are going to be what? It is going to be weak electrolyte because it is made up of weak electrolyte. But if you talk about the another one, NH41, so NH3 plus HCl. So this is the weak base, but it is a strong acid. So the salt will form NH4Cl. It is the strong salt. It is going to be strong salt. Now see,
Mhm.
they are saying that is OH minus ion concentration decreases. What is the reason? Hmm.
Uh, I think the reason for this would probably be that NH plus 4 is the common ion.
Hmm, hmm.
So if so this is basically going to be the same, that it's going to cause the reaction
Hmm.
to move in favor of
Hmm.
to the left,
Yeah, yeah, correct. You are saying, see,
because
it is. Mhm.
and then it's going to cause OH to decrease.
Yeah. So it is going to be the what? Reversible NH4 plus
Yeah.
OH minus, and another is there NH4Cl. It is 100% dissociating. So NH4 plus, and here is Cl minus. They are the common ion. Common ion, the concentration of NH4 plus is increases. So NH4 concentration increases. It means what it is going to be happen. What it is going to be happen according to Lee-Chatelier principle, equilibrium reversible will shift in the backward. Reversible reaction is going to shift in the backward. So what we are going to get, that is which is going to combine, which two is going to combine, that is NH4 plus and OH minus will combine, so that it will go back, means OH concentration is going to decrease. Yes or no?
Yeah.
Okay, can I erase this?
Yes.
Okay, next one, let's have a look over the next one. Buffer solution. Buffer solution, what is buffer solution? Have you seen, have we ever?
Uh,
Hmm, hmm, hmm.
so from what I've heard, a buffer solution is basically one that resists a pH change.
Hmm,
So if we have like if we add like we have a base and we have a base at 8 pH, and
hmm,
we have an acid at 2 pH,
hmm.
and we add, and let's say we bring it down to sort of 5 pH, a buffer, if we add a buffer, it's probably going to bring it down to like 7 or 6 and not all the way to 5.
Thank you very much. You are saying that is all correct. So buffer solution means the, you can say the solution which, what they are saying, which resist to change in its pH, to change in its pH. Okay, in its pH. This is what the buffer solution. Now, when you talk about these cases, if you talk about, so how the composition, if you talk about the composition of buffer solution, composition of buffer solution. So buffer solution always composed of two things. What? That is first one, if you saw, that is a strong acid. No, not the case of this one. Firstly, what we are having, suppose we are having weak acid. Okay. So if you are having weak acid, so that is salt of, they are saying another is salt of weak acid. weak acid with, this is the strong point, important, weak acid with a strong base, weak acid with a strong base. Okay, this is first. Of second one, they are saying if you are taking the weak base, okay, so what we have to take, that is salt of weak base, WB, with is strong acid, with a strong acid. That is what you need to keep in mind. Okay, so that is what, that is the, if you talk about buffer solution, so they are made up of what, either weak acid or weak base. That is what it will be large in a quantity. And if you are adding the salt in that one, so salt should be the strong salt. Okay, salt should be the strong salt that we
I
have to.
just have a quick question.
Hmm.
So does a weak acid mean a strong base, and does a weak base mean a strong acid?
Hmm.
Like,
See,
can this be like strong acid plus salt?
no. CH3COOH, this is the weak acid. Yes, yeah, no.
Mhm.
Now what we are going to add in this one, we are going to add that is CH3COONA. Now you see, this is the is weak salt of, you can write this one, salt of weak acid with what, with a strong base. How? See how you are going to get Na. CH3COOH is there. If you are adding, that is NaOH. This is the metal base, na, metal hydroxide. So it is going to be strong base ACNO. So here it is
Yeah.
taking H, and here neutralization reaction. So water is getting out. So that is, here is minus H2O. So what going to form? CH3COONA. So they are what? The salt of weak acid. Now this is weak acid with a strong base. Salt of weak acid with a strong base. Is it okay?
Mhm.
Similarly, if you are taking weak base, so suppose I am taking NH4OH. So they are saying that is, you take the weak base, same base, but salt with a strong acid. So what we have to take? NH4Cl. Yes or no? You
Hello.
getting this?
Could you repeat the last part? My headphones disconnected.
What I'm saying, that is this one, you see, weak base. Okay, this is weak base. The second case I am talking about
Hmm.
is a case one. If you are talking about case two, so it has the weak acid or weak base. So weak base, but the salt you have to take, that is salt of weak base with strong acid. So NH4OH is the weak base. Just now I told you weak base. But this is what? Salt of weak base with strong acid. How? Suppose NH3 is there. This is the weak base. But if you are treating with the HCl, so that is a strong acid. So if you see NH4Cl, it is going to be what? Salt of weak base with strong acid. Is it okay?
Yeah.
This, so this is what that is. Salt of, we can write here, salt of what? Weak base with a strong acid. Is it?
Hmm.
So this is what the
Yeah.
case of the buffer solution, right? So what we need to do, you need to, can you please write down this one?
Sure.
So the solution which resists to change in its pH is called buffer solution.
Hmm.
Can I erase?
Yes.
When is your exam? Is evaluation is going on there?
Sorry.
When is your evaluation process, exams process in your college?
Yes, my exam is in, it is on May 7th. So
Acha.
approximately 2 months from now.
Oh, okay, great. Too much time is there, means you can score better. Okay, great.
Yes.
So that is the if you are talking about the types of buffer solution, okay.
Hmm.
So two types of buffer solution are there. That is the very easy are there. First one is called acidic buffer solution. Okay. Can you please tell me example of buffer solution?
Example of buffer solution. Mm, Example of buffer solution, I think can be.
Human blood is there. Human blood. Animal
Oh
blood,
yeah,
that is
human
one.
blood.
See,
Mhm.
whatever amount you eat acid, the pH of blood has to be remain the same. Okay, so that is what human blood is the example of buffer solution. Now there are two type of buffer solution are there. Okay, acidic buffer solution and basic buffer solution. Both cases, the pH they have to resist, but here is what that is, pH is less than 7. pH is less than 7. pH resist, wait, I'm writing. pH resist to less than 7. pH resist at less than 7.
Mhm.
Okay, that we have to, which is less than 7. So acidic means that is less than 7. Composition. Okay, composition. This is very important. Composition. So that is what weak acid plus what is salt of weak acid with a strong base. This is what the composition that we need to keep in mind. This is what the acidic buffer. If you are talking about basic, so basic buffer means pH resist, which is more than 7, which is more than 7. Composition, if you talk about composition, what is the composition? So that is weak base plus salt of weak base, with salt of weak base with is strong acid. Got
Mhm.
it?
Right.
Okay. That can you please make a note of it?
Yeah.
Hmm. You can do some of the problem based on it.
Written.
Okay. So the second portion we have to do, that is calculation of pH. Here we are going calculation of pH. Calculation of pH. Okay. So how can you calculate? That is the case one. Case one is for acidic buffer. We are going to calculate for acidic buffer. Okay. If you talk about acidic buffer, you need to keep in mind, it is calculated by Henderson equation. It is calculated by Henderson, H-A-N-D-E-R-S, Henderson equation. It is calculated by Henderson equation. And what is the Henderson equation? If you see, pH is equal to pKa. This is the pKa plus, they are saying, log salt upon acid, concentration of salt upon
Mhm.
concentration of acid. Okay, this we have to see. Or you can write that is pH is equal to pKa plus log, that is A minus. A minus means conjugate base. Negative charge or base, I told you in the Lewis concept. A minus upon, that is Ha. Ha means what? Acid. It is going to give Ha. No, that is what? Ha means what? That is, it is going to give H plus ion, so it is going to be acid. So this is what the formula which you have to keep in mind. Let me check out the sum of the problem. If I'll get, we can solve out. So let's try to solve. Please wait a moment. This is the case one we are going now. So I'm checking the problems. Well, fine. I got the problem. Can I erase this one?
Yes.
Okay. So let's try to have the questions. A solution, here they are saying, a solution is 1 molar. A solution is 1 molar in CH3COONA and 0.1 molar CH3OH if pKa. What is pKa? If you are defining na pKa minus log K, it is used in the calculation. Okay, pKa is nothing but that is negative logarithm of Ka. Ka means what? Acid dissociation constant. This is what?
Right.
Acid dissociation constant, like just like the equilibrium constant that I told you during the ionic product of water it came. So a solution is 1 molar in CH3COONA and 0.1 molar CH3OH. No, COOH, CH3 COOH. Wait. If pKa is 4.8, find the pH of buffer solution. Can you solve this one? Find the pH of buffer
If
solution.
pKa is 4.8
Hmm.
and 1 molar of CH3 and 0.1. Okay, so it's going to be salt divided by acid. So it's going to be, so 4.8 plus the log of 1 divided by 0.1. So this is going to be
Log 10 is equal to 1.
log 10 is, yeah, so this is going to be 5.8 A.
Yeah, this is the correct answer. So you already got to know the answer. Here, one more problem. Can I write the one more problem?
Sure. Yeah.
Can I erase this one?
Yes.
Okay, thank you. Question number 2. So that is they are saying an acidic buffer. An acidic buffer contains 0.06 molar salt and 0.02 molar acid, and the dissociation constant and the dissociation constant of acid is 10 power minus 4, then find the pH of buffer solution. Find the pH of buffer solution. Now solve it. Option they have given 4, 10, 4.48, 9.52.
So
Right.
this is this is going to be so 0.06 salt and 0.02 acid. And then this. So will this be 4.48 C? Because I have, so the first thing I do is find the pKa, which is going to be the negative log of the dissociation constant. Then I will do the log of concentration of salt, which is 0.06 divided by 0.02, which is the concentration of the acid, which gives me 0.48. And then I just add the two, which is going to give me 4.48.
So that is okay. You are saying that is 4.48. That is correct one. Thank you very much. You got to know this one. Huh? So let's try to solve the next one. Okay. So what is the next one? Can I erase this one?
Yeah.
Okay. Case 2. This is we are going to case 2. pH of basic buffer solution. This is the where basic buffer solution, pH of basic buffer solution, pH of basic buffer solution. So how can you solve basic buffer solution? So here they are saying POH is equal to, pH you are not going to get, POH is equal to PKB, right, plus
Mm-hmm.
log, they are saying salt upon, log salt, concentration of salt upon, it is going to be concentration of base. Okay, or that is, you can also write that is POH is equal to PKB plus log, it is going to be conjugate, it is going to be what, conjugate, what will be there, it will be the acid, in this case it is going to be acid. So here is what, that is acid, this is the acid, upon it is going to be what, this is going to be, that is base. Okay, so that is acid means conjugate acid, that is conjugate acid base concept we study now. Similarly, that one is there. Now, this is the concept. So from this one, you are going to get what? POH, right? From here, you are going to get POH. Then what we have to apply? pH plus POH is equal to 14, that you know. So pH is equal to what? 14 minus what? POH. So by this concept, you can be able to solve the problem. Will you be able to understand this one?
E-
Can I erase?
One second. I didn't quite understand. So what is, oh, so pH is equal to 14 minus POH.
Hmm.
And then, so PKB is the base constant,
Base dissociation constant
right?
minus log
Uh,
KB. See, PKB is not, that is they are not having. It is the negative logarithm of what, base dissociation constant. Like pH
okay.
definition is what? That is negative logarithm of H plus ion concentration. Now, so
Yeah.
similarly, PKB concept, what is the, how do we define? It is mathematically only, logarithmic we define. So negative logarithm of the base dissociation constant.
I-
Getting?
And so we don't use a salt in this equation. We use the conjugate acid.
Here salt is there now.
Oh, salt. Oh, sorry. I was looking at the boxed equation.
Both are the same.
Got it.
Mm. Depending, that is in your book generally, in here in India, we teach how that is salt upon base, it become very easy. But what happened, to teach the other student, they don't know what is conjugate acid, so how can we teach? But we know that is base have conjugate acid and acid have conjugate base. Getting?
Hmm.
So that is, if the basic is there, so upside what will be there? Conjugate acid, simple is that. And we know this concept, pH plus POH is 14, that you know very well. So pH is equal to 15 minus POH. So this, you can be easily applied this one. Can I erase this one?
Yeah.
Okay, thank you. Let me write the problem. I'm not solving any of the problem because you are able to solve all the problem. So
Hmm.
I'm not doing anything. You are by yourself, you are doing. See, what is, they are saying, what is the pH of a solution? pH of a solution. What is the pH of a solution obtained by mixing? They are saying obtained by mixing 100 ml of each, 100 ml of each, 0.2 molar NH4Cl and 0.2 molar NH4OH. If pKb of NH4OH is 4.2, is 4.2. So they are asking pH. So okay, option A number 10.8, B number 11.8, C number 10.2, D number 9.8. So
Okay. So
you solve
PKB
it.
is 4.2.
Mhm.
And then we have NH4Cl, which is 0.2 molar, and So NH4OH is the, so we do 0 point, so this is going to be log, so hmm, what is the pH of a solution? So pOH will be 1.2. So will this be 9.8?
Yes, correct. Only 9.8. The number is correct.
So this is going to be log, so this will be 4.2. So pOH is equal to 4.2 plus log of 1, which is 0. So 4.2, and then pH is going to equal 14 minus 4.2.
Hmm. So yeah, that is okay, na? Correct only, na? You understood, na?
Yeah.
Okay. One more problem, very short problem I'm giving you. If you solve it out, even this directly you can apply this formula also. pH is equal to 14 minus pOH is there, so we can apply now 14 minus what? That is pKb. Yes,
Mhm.
plus log what? Salt upon base. Yes, yeah, no.
Yeah.
That is also a short way you can apply this formula also. Okay, so pH you can easily get. There is so many way. Okay, how faster you are imagining the question. Let's see, that is if you can solve this one. Very easy one. Concentration of, they are saying, NH4Cl. Simple question. NH4Cl and NH4OH. They are saying NH4OH in a buffer solution. In a buffer solution are in ratio. How much they are saying? Of 1:10. 1:10.
So
KB
this will
for,
be,
okay, PKB for NH4OH is 10 power minus 10. Okay, 10,
mhm.
no, PKB not KB, sorry. 10 power
Yeah,
minus
that
10.
would be KB.
KB, 10 power. Then pH of solution. They are asking pH of solution. So it's
Okay.
very easy one. 4, 5, 9, 11.
So this is going to be 4, 5, 9. So this is going to be, so pOH
Hmm.
will be uh, so KB is 10 to the negative 10, which means that the pKb is 10 plus, so this is going to be NH4OH divided by NH4Cl, which is going to give me negative 1. So this is going to be 9. So the answer is 5.
Yes. Thank you. Correct one. Can I erase this one?
Yes.
Okay. So next one is the, already you got to know the buffer one. Mechanism is also there. It will take time. So next class I will teach you the mechanism. Okay.
Okay.
Buffering activity. Here little bit you see the some more problem. Here is another is buffer capacity. It is also there in the your syllabus. Buffer capacity. If you talk about buffer capacity, we talk this buffer capacity. So how can you be able to understand buffer capacity? See, how can we be able to make you understand buffer so they are saying it is capacity or power, you can write. It is capacity of solution. It is capacity of solution to, they are saying, absorb amount of protons, H plus ion, H plus ion, H plus ions, or OH minus ions, without without major change in pH of solution, Okay, That is the definition is important here. Anybody can ask. So basically buffer capacity means how much it is going to absorb the H plus ion so that pH is not going to change. If it is acidic buffer, if it is basic buffer, how much OH minus ion it is going to absorb so that its pH is not going to change. So this is what that is, the buffer capacity. Can you understand this definition?
All right, yeah, I got it.
Yeah.
So it's basically how much the buffer can actually resist the.
Yes, 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 yes. Resist the pH even though we are having the H plus ion or OH minus ion. If you are the one can add only acid or base. So if suppose someone is adding the H plus ion, so how much it is going to resist to change in pH even though absorbing H plus ion. Okay. Or that is you are adding the base, so how much it is going to resist. Okay. So without major change in the pH, that is what they are talking. Is it okay?
Okay.
The based buffer they are talking about, the based buffer is that buffer which have, they are saying which have concentration of, okay, salt, okay, salt, or I'm writing A minus equal to concentration of acid. Okay, if both are the same, suppose I am writing if A minus, here is we are writing A minus upon HA, A minus upon HA is going to be 1. So good buffer, it is going to be good buffer. It is, they are saying that is good buffer, that we need to keep in mind. Okay, so in this case, what will be there in this case? So that is pH is equal to, you are saying pH is equal to, suppose pK is there, okay, plus what we are adding log salt upon what we are there. Salt means we can write in the conjugate case, in the case of A minus, that is base upon what we can write, that is going to be acid. Now what they are saying, that is both concentration is the what, both concentration is same means they will be cancel out. So that is pH is equal to, that is going to be pKa plus log what is, that is 1, and log 1 value you know very well, that is 0. So pH is equal to what will be there, pKa. Getting? Okay, note is there, very important note is there, if ratio of no, A minus upon acid, okay, A minus upon acid are same, then pH will also be same, in bracket always. Getting my point? No matter about amount, no matter about amount.
Okay, so if the ratio of A minus and if the ratio of the salt and the acid are the same, then the pH will also be the same.
Are you be able to understand this point?
Yeah.
Maybe suppose you are adding, that is the 1050, or suppose this ratio, if you suppose you are adding 10, this is 10 and here is 100, so it is going to be 1 by 10, or you can add 1 upon 10, simple 1 ml and 10 ml. 1 ml you added the base in acid, salt in acid, the same will be there. Getting my point? So this is what the characteristics, some points behind this one. So this is all about the buffer. Okay, so next point, if I will teach, acha, okay, I'm giving you some hint, but we need to study little bit this one more. Okay, titration, do you know what is meaning of titration? This is there in your syllabus, titration.
Titration, I think it's like I've done the lab before where you have like the I don't remember it clearly, but you have some liquid in the bottom and you try to put some indicator in it and it turns pink, I think.
Yes, yes, yes. Good, good, good. No, this is not. There are self indicator is there, like per magnet is there, KMNO4. There you are not using the indicators. Like always you are not going to use the indicator. Some are the self indicator. Okay. So suppose you go, if you are using Mohr Salf against the KMNO4, you do not use indicator. But if you are, suppose you are having oxalic acid with the sodium hydroxide or some other base, so there you need to use the indicators. Okay, so titration means what? If you are writing the definition of titration, it is method, it is method used to determine what? It is method used to determine the amount of acids or base required to neutralize the unknown solution. Getting my point? So suppose you are having suppose some acid are there, right? Acid, and acid is having, they are saying unknown, it is unknown concentration is there. So how much base required? Base is, suppose you are having 25 ml is there, okay, and 25 molar is there. Suppose 1 molar is there. I'm telling you very short way. 1 molar is there, 25 molar. So what they are saying, or 1 molar, simple you write 1 molar. 1 molar means 1 mole per liter. So they are saying that is how much base you are using to completely neutralize the particular unknown concentration of 25 ml of this one. Okay, so they are asking, that is the amount they are asking. So these type of things are known as titration. Up now in our syllabus, what we have to study, they have asked in the titration and pH curve in your heading. What they are, titration and pH curve. Titration means this much only, that is you have the burette. Have you heard about the burette?
Yeah.
Okay, so with the burette is having the unknown. Okay, burette is having the unknown solution, unknown acid or base. Here is the unknown are there, and then one is there in the conical flask. In the conical flask is there, that is known is there, this is known. Okay, so what is there, you are dropping this one drop by drop. Once the color change, okay, that is called equivalent point. Once the color of this solution is going to change here, the beginning of the color change, that is what is end point, that is called end point. End point means what? That is, you can say titration point, and you have to stop at that point. Okay, titration point or equivalent point means that is the down one is already known. How much? Suppose 25 ml you have taken, okay, 1 molar you have taken. Then this one is how much amount is going to utilize. Here readings are there, that reading you have to note. Getting? Then you have to apply the formula m1 v1 is equal to m2 v2. So here the volume you are going to get, yes or no? So that is one is known. So here volume you are going to note from this one in the milliliter ml. It will give that is how much utilize. Getting? It is method to use to determine amount of acid or base required to neutralize unknown solution. Okay, so or the known solution, whatever it can be, that is what I'm saying. Here you see, so volume is, you are able to understand this much, how much is their volume using. So m2 you can, strength you can easily determine, m2 is equal to m1 b1 upon what it will come, m1 b1 upon v2, this way. Now see this way. So what is going to happen here? What is going to happen? Let's see the basic idea. This idea, are you able to understand this basic idea? Okay. Now we are having the titration curve. Titration curve. So titration curve, basically in your syllabus, what is there? pH versus that is volume use. pH versus volume use. Okay, pH versus volume use. So suppose in the one axis you are using the pH change, and here is volume. There are the 3-4 cases are there. Case one, if you are talking about strong acid, okay, and strong base, do not need to write, okay, strong base, because I need little bit more time to explain you. So strong acid and strong base, at the end point, if you talk about end point is 7. End point is going to be 7. Okay, and how the curve is going to be? Curve is initially if you are adding the volume, increasing the volume, so pH slightly will get the increase. pH is going to be increased. Suppose the highly acidic is there, adding the water, so what will happen? pH will slowly the strength will decrease and pH will going up. Yes or no? So the curve is something like that. If you talk about the curve, you can read out. Once you read out the book, it will be easier to understand. See, this
or
type.
second S curve.
So this is what this point is going to be here. This point is known to be end point. Okay, this is the end point. And this is end point, or it is called also called the equivalent point. Here the complete neutralization takes place. pH is equal to 7. At that point, pH, after that here pH is increasing. Here pH, maybe here is the pH is 10. Here is 0, here is 7, here is 10. After that, if you are keep on adding, so pH will keep on increasing. So so what is that is end point, where end point you are going to get? Here you are going to get the end point. pH is equal to 7. It is called equivalent point. Here is the complete neutralization takes place, right? So this is the case of the concept of what that is the titration. In the next class, if you study this one, that is also okay. If you study other things, also okay. In the next class, little bit what information is there? Titration, I need to give little bit more information, and action of buffer.
All right, sure.
So this action of buffer will require little bit 20 minutes. That is why today I didn't taught. And that is titration. It is also 20 minutes. So that is around 40 minutes I require this topic. So can we do in the next class this one?
Yes.
Okay. So bye. Take care.
Thank you, sir.